Good afternoon to all of you. Let me add my own note of welcome for all the participants for the next 5 days program on finite element method. Yeah, using ANSYS or any software does not matter, but at the same time, I mean, it's so important to understand the aspects of the FEM. That's very, very important. However, I am not an FEA or FEM expert, but I spent my whole over 3 decades of my life only on product development, right from concept to the product which is being delivered to the customer. The entire process of manufacturing activities had been involved, very specially on metal cutting machines and SPMs. Just to set the context for the today's subject on my perspective, we all, in my experience, when I started my career in 80s, I think even though it was there, finite element, but of course it was not that popular, especially in capital goods manufacturing. But still products were made and delivered. Doesn't mean that the products are not working. Efficiently working with the greater reliability beyond our expectations. So how that was made possible? Because we used a number of experiences from the shop floors, the learning and the experience of the knowledge of failures of the product were playing a huge role. And we used to make a collective, the reviews of the concepts and design. And during the design of any product, of course, we had no even softwares also, but we used to work on the drafting board. But still, from the point of to make a better trade-off, I would say here on the product, reliability and efficiency of the product, and as well the cost. These three are important factors which is getting appreciated by the customer. He wants most reliable product, most efficient product, and as well at the lowest possible cost. But trading off between these three was a really challenge. But that was not sufficient enough, because customer day on day, he become most stringent in their requirements. So that's the thing which made the software to come in, because we used to develop the product and find out, is there any such kind of optimization in the product in terms of the structural, or in terms of the reducing the material or reducing the manufacturing process. These are something that we used to do after the development. But now we do not have so much of the sweet time to spend so much in the product development itself. Customer wants very quickly the product, because the products are getting obsolete very fast. It was not the day like in 80s and 90s where a product will run for so many number of years, but it keeps changing now. So in that scenario, probably nothing other than that, we have to adapt the system or the analysis tool called finite element method, so that the first product comes at the first or the right time, at the fastest possible to the customer end. So this is why now it has become more popular. And just to add another couple of points, that my customer, why does he require an optimization in the product? He may not be. He is required a better product at lowest possible cost. But as a product manufacturer, I look at what should be the competitive price in the market, because I cannot sell at highest cost. He is not appreciated. At the same time, I do not optimization. I cannot sell the product at under cost also, or under price also, because I would, of course, I'll have to make some money. There should be some money is left on my table to do so much of activity. So the best and the better way is optimizing the whole product before we develop, because development also takes a huge amount of money as well as the time. So my customer never appreciates my product something which is not adding any value. Every product need not be do the best. What is the objective of the product that has been conceptualized is the one which makes me as a designer to think about what could be the best way to do or develop a product in terms of the geometry, in terms of the material, in terms of the size. And of course, at the same time, it has to give a better life also. Reliability also should be there. So these are something which makes every manufacturer to think every day what can be done to save even 1 gram of material. So in this challenging world, my customer is always looking for these kinds of, most optimized. Another important factor is today is weight to stiffness ratio. It's not in our time we used to give any amount of weight. That was, it was not matter for us so much. But today, even any product which is a lightweighted, at the same time, without compromising on any of their behavioral aspects in terms of the strength or a stiffness or reliability or a wear and tear or any aspects, if without any variation, if you make it as light as possible, I think that's one which is getting appreciated from any customer in any product segment. It's not only to the machine tool or an automotive industry or a pharmaceutical industry machineries or agriculture machineries or wherever it may be, whatever maybe the product is being developed, the weight to stiffness ratio is the one every industry is working very, very hard on that. So that could be possible to achieve is only through these, the, the methodology or a method that is going to be discussed in the next 5 days. Um, just bring a few aspects of what we are focusing in this. Of course, the 3.5 hours and 5 days is not enough to learn, but it can give an eye-opening. It can give a how you can proceed during your practices. So what can be done using the kind of tools that are available? What are the necessary or essential things that we need to learn before we get into the platform is the one which we'll have to look in from this program. I would say that basically we need to understand what is all about finite element analysis or a method. By and large, people who are here, except few of you people, may be aware of the basics of FEA and general steps that need to be followed in this method: boundary conditions, types of elements, interpolation models, and something similar to that. Coming to ANSYS per se, I don't think, it's also one of the very popular tool, and it also needs some more time to go more deeper into that. However, we are also getting into the software called ANSYS because our faculty is a good amount of hands-on experience using ANSYS. But he will also touch upon the other softwares which are available online without much of cost, where you can also touch those areas to optimize the products. It also depends on the nature of the product, the complexity of the product, that you need what kind of software to be installed in your organization so that it can help us. Not everywhere ANSYS can do, not everywhere such a complex or a high-end software is essential, but you will have to take a call on that what can be, because cost is also, investment is also a part of your business. Then coming to the analysis procedure, there is a preliminary decisions has to be made, pre-processing aspects has to be looked in, post-processing aspects has to be looked in. You have to create a model, or you have to import the geometry or a model in various formats. What are those different types of formats? What kind of the native commands that need to be addressed? Geometry creation, how do we do that? What are the different types of coordinate systems that are being followed in these platforms? Then how do I create a finite element model itself? Because we just import the 3D model, it cannot just go inside. You have to convert that into a finite element model. So these are some of the areas that faculty would touch upon, and defining the types of materials, what kinds of loads are coming at what direction and what point is also a matter. So how do I fix this in the software is also a one which we would touch upon. Then when it comes to the types of analysis, what we are going to do in, depending on the product, we may not do all kinds of analysis for all the products. So that decision is to be made by an organizer or a designer. How all these aspects. It could be a structural analysis, it could be a thermal analysis, or it could be dynamic with linear and non-linear, many areas that we'll have to look into that. So we have defined this program in such a way that at least look at few aspects, how confidently that we can learn and we can implement in your own organization. So this is what we're going to do in this next 5 days. As Ramesh introduced, Mr. Bharat is an expert of FEA, and he has done number of programs to IMTMA our own students as well, the fresh engineers as well, some of the industry experts also. So I don't think we can have a better than Mr. Bharat, anybody else in this program. So I welcome Bharat once again on my behalf.
So let me, my entire course, this course will be something like this. The course content, I have written a course content. We'll be going through something like what exactly is the design process. Okay. In between, I'll be trying to share the whiteboard also, so that I'll be able to write it and explain you guys what exactly is this. So basically, we'll be starting with design process and why analysis. This basic things I'll quickly run through this without much wasting the time, so that I'll try to go through directly answers, analysis, FEM concepts, and what are the different methods of analysis. How do we understand this? And numerical methods. Why exactly this numerical methods? What are the different types of numerical methods we have, and how exactly we are going to approach this numerical method? What is this numerical method, and how this FEA came into picture? What is the approach which we will be trying to do it? Then we will understand what is FEM and capabilities of FEM, different types of finite element analysis. What is the method and analysis which will be working, and few case studies I'll be trying to introduce you to applications. So this is a theoretical part with slight kind of numerical concepts which I'll be trying to introduce in numerical methods. Later we'll be going with finite element analysis, where we'll start working on what exactly is FEA procedure. I'll be trying to talk about here two types. One is what exactly happens in the front end, and what exactly parallelly I will be discussing what happens in the back end, and how do we correlate this front end and back end, and if we have any issues, how do we solve these errors? This is what exactly we'll be trying to work on that. And parallelly, we'll be working on the case studies, or I can say that hands-on sessions, okay, on linear static analysis, dynamic analysis. Okay, we'll be working on thermal optimization studies. In the process, I'll be introducing you to two different softwares. One is ANSYS and SimScale. Okay, I'll be trying to talk about this area. So, and also why I've done this case studies here is this linear term. I'll try to include your expectation one of the hands-on sessions which can cater to your needs, and try to explain it. And FEA, guys, before I talk about FEA, FEA is a ocean, because you would have experienced 5 days making all of us. It is not only you guys, it is a learning process for me also now, because this 5 days is a challenge, quite challenging for me, because 5 days 15 hours where I'm going to talk about FEM. Okay, which I need to ensure that you can able to work. That is what I have understood. You will be able to work by yourselves, so that you can do that. So it is a quite challenging. I'll ensure, hope I'll at the end of the day I can do it better. Now, in this case, let me start without delaying it. Let me start with this answers. Guys, let me start with something called as a design process. Since you are into product development, okay, most of you are in product development, I'll be to start this basics of this one, and why analysis comes into picture. Uh, in this design process, whenever you start, as you know it, design always starts with a need. So this is what exactly the design process starts. When I say it starts with, it has basic steps. Now, why this steps came into picture and who has done it? It is in nature. It is in nature, guys. Try to understand the process which I'm trying to explain. It is not defined by any other person. It is by default in nature. Okay, so need, you have got definition, synthesis, analysis, so many steps are there. Let us understand each stage and why there is a basic requirement of analysis. We'll try to go ahead. Now here, when I talk about a need, as we have spoken about analysis, okay, need is the mother of, okay, necessity is the mother of invention, we call it as. Now need can be either you are going to create something, okay, or you are going to modify the existing terms. That is what we call it as a need. Okay. Now, either you are going to create a new product, or you are going to modify the existing product. When this need is defined, need is comes usually from the customer point of view, or if you are trying to create a new product, it can be a need here. Now, this need, we go for a definition phase. We try to completely define what exactly we need. The definition includes the purpose, what exactly we are going to create. the material cost, so many other parameters guys. So each and everything, whatever we have defined the previously, we'll be trying to redefine each and everything. It is a teamwork which works because it is not only a person, single person which will be doing it. We'll be trying to define in different perspectives. Once we have defined completely, we have understood our need. This phase, this definition phase can be called as understanding phase. It is complete understanding of your necessity, okay, the requirements. So once you have understood, including the time, how much time is allotted for your project. So everything once you are done, the next stage we go for something called as synthesis. What we do is we talk about the prototype models. Okay, I'm trying to talk about the conventional designs of the prototype models will be developed and perform analysis. Okay, try to develop 2-3 prototypes. Nowadays, prototypes are being done on the computers, virtual prototypes we call it as, and it is done. Then we go for something called as analysis phase. This is where exactly analysis. Now, analysis and optimization is our major study now in this case. Why analysis and what kind of analysis which will be trying to do it. Now in this case, once analysis is done, then this process is iterative. After you do the analysis, then we go for something called as evaluation phase. We evaluate it, whether our analysis is catering to my requirements of needness and definition phase, whatever I have defined, whether this analysis is happening or not. So this is a iterative process. Then we document it. Later from there, we go for the manufacturing sectors. So basically, before manufacturing and after modeling, after synthesis, there is something called as analysis, and we'll try to understand why exactly we'll be trying to do this analysis. So our focus from this point of time, I would like to take you from analysis to the finite element parts. Why analysis, guys? Whenever I talk about analysis, there are two important questions which we need to ask. One is why I should perform the analysis and how to perform the analysis. Very simple answer is why exactly we are going to perform the analysis in your product development or at every stage. Analysis will be done. There are two basic reasons. One, either you go and do the optimization or you're going to validate your results. There are only two basic things. When I say optimization, to get the maximum benefit from the available resources. So when the customer comes and asks you, obviously try to tell me whether this particular structure will withstand the load or not, or what is the lifetime of this particular structure. Now our answer cannot be your lifetime is only 1 year. See, let me say this product he came, he is using a product, and suddenly he understood that his lifetime of the product is one year. This cannot be our answer. My answer should be something like this: yes, at this point of time, it is 1 year. With this changes, this can be increased. That will be your optimization. So optimization is utilizing the available resources and giving the better results. So the solution part, that is what exactly solution is not finding the values. Value is not a solution. It is always the solution is intangible. Okay, now intangible to the customers. The tangible quantities is what analysis will give, but the post processing is always intangible. When I talk about intangible, it is something called as quality, which we'll try to improvise in this product. That is what exactly optimization and validate, guys. You are going to validate your design, whatever you have designed, from the available standard requirements. These are the two basic focus on analysis. Still, in depth we'll go about this analysis. So at this point of time, two types of analysis. One is optimization as well as validation, guys. So in this case, the methods which I'm trying to talk about, just now I've gone through, shown the two methods, analytical method as well as numerical method. Now here, the numerical method is very simple, guys, because it has got a standard governing equation. From the governing equation, very few variables are there and simple geometry is there. We can easily calculate. But in case of numerical methods, there are more complex equations. No existence proof of existing equations. I do not have such equations which is readily available. No one has derived. When I say bending equation, someone has derived it for me. Yes, and I'm making use of that equation to develop the next areas. But in this case, I do not have, because more complex problem and more real-time challenging equations are coming into picture. So in such cases, I cannot work on that. And here more number of variables are coming into picture. It's only not only x and y. Time dependent analysis I need to do. The parameters keeps changing with respect to time. In such cases, what to do? And most importantly, the geometry base. The geometry is too complex. So you do not have any other choice except numerical method in this case. And one more method is there to perform the analysis is experimental method, which we usually do not depend, because when I say experimental method, it is done only on kind of specimens. Okay,
Right.
not exactly on every stage. So any questions, guys? Anything you'd like to ask me?
I think in practicality, the numerical methods are much closer than the real time problems when you try to
Yes,
solve it
yes,
through FEM.
yes, yes.
Because,
New, yeah.
because we have to set up our boundary condition according to part geometry, part constraints, and everything.
Correct. What you said is true, exactly, because numerical methods are more closer, because it is what we need to do is the numerical method is what exactly happens in real time situation. It is not the analytical method, because every stage the problem complexity of problem keeps on changing, right?
So, Dr. Bharat, generally what we face while using ANSYS or anything, we face problems with boundary setting only.
Yes, yes,
So we
yes.
will cover that when you will be
Yes,
on the.
100%. I'll be covering it. I'll be
Yeah.
trying to cover it how exactly body is doing. I'll be because you need to understand more important thing is context.
Right.
Okay, right. So it is the context which you need to understand. I'll try to explain how the context works, what kind of
Okay.
contacts each and everything. So that how do we do it when two elements objects are in contact? How exactly this contact can be done? Then one we call as master contact and one is called as slave contact. So I'll try to talk about this contacts when it comes to boundary conditions, right? Right.
Okay.
So yeah, right. Not an issue. So let us continue. Now, numerical method is what exactly it works, guys. So most of the times it is not the analytical method. Most of the time we will be trying to work on numerical methods. Now, still, what are the different numerical methods? The question now comes. So we are satisfied, as I was trying to talk about. There are different types of methods. One is called as analytical method, a numerical method, and experimental method. Experimental method is ruled out by default because we don't do experiments on all the types of components. We go for analytical method. And when I say analytical method, it has comes with certain restrictions because existing equations should be there, should be available. Unfortunately, such equations are not available at all the time. Then numerical method. Numerical methods, geometry is complex, but no other option, guys. Other than numerical method, no other option. Because everything we need to choose here. Starting from the boundary conditions, what kind of we need to understand. The best part of numerical method is yes, it not only helps you, it will try to understand, improve our ability of thinking. That is what the numerical method does. So what are the different types of numerical methods? Few I have shown here. There are many types of numerical methods. We have called as Rayleigh-Rich. Mathematically, if you go, we call as Rayleigh-Rich method, Galerkin's method. So many different methods. Gauss eliminations comes in picture. So many methods are there. So popularly, which one became popular? Why they became popular? Let me explain you this. Here, we have something called as finite element method, finite difference method. We have something called as finite volume method, boundary element method. BEM is one of the famous method. So each method came into picture, and these methods became so popular. Okay. Now among this, people started using this methods for structural mechanics. It became popular, but still can be used for other methods. In optimization, FDM can work. Okay, finite volume method, computational fluid dynamics, they keep working on finite volume methods. At this point of time, what happened is FEM became so popular that it started working on this optimization flow studies. CFD also, yes, FEM started catering nowadays. And what FEA can do for us? This also I'll try to quickly run. The reason is why I have shown this is we need to understand what are the capabilities. Then only I can make use of this particular. You got a new product or new mobile. Try to first thing what we do as soon as the mobile comes, we try to test all the features of it. Then we start making use of it. Later we'll understand what features will be better suitable for us. So let us understand what exactly are the capabilities of FEA, what FA can do for us. So works on structural problems. Okay. When I say structural, it can be linear, it can be non-linear. I'll be trying to talk about in depth of this numericals, linear and non-linear. Stress analysis. Okay. Stress concentration problems where stress keyways are there. Suddenly stress concentration will be there. There is a crack in the structure. There will be improved stress concentration. Would have happened. Buckling analysis, vibrational analysis. Where we'll be working on that. The non-structural problems, especially most there are some areas where exactly you are working on this non-structural analysis, like Krishna Singh has mentioned, you are working on CFD kind of things, non-structural analysis. Okay, so in such cases, how this FEM is going to work? Thermal analysis, temperature distribution, Now biomedical analysis. Okay, so yes, this is the area which is coming up nowadays. Biomedical analysis, nuclear engineering. Okay, geomechanics. In case of we don't, this one is like archaeology department, which they'll be using it. Analysis of excavations, all the things they'll be working on that. And the types, guys. I'll be trying to go deeper and deeper into FEM. At any point of time, you can stop me and you can clearly ask me the questions, or you can put me, ask me the questions in chat box. Okay. So guys, types of finite element analysis. There are different types, which we'll be trying to go through it, because we'll try to learn the concepts by understanding these types of analysis. Linear static analysis. Okay, when I talk about this linear static analysis, like structure of the major outcome is the displacement, guys. Here in this case, the major outcome which we would like to know is the displacement. So we have something called as linear static analysis, where the deflection calculation, context stress computations, which we're trying to do it. We have something called as vibration analysis, where exactly Mr. Robin is interested now. Okay, in frequency and buckling analysis. We'll try to work on this kind of analysis also, Robin, where it includes we have frequency, harmonic analysis also. We'll be trying to do it under force vibrations. We'll try also study eigenvalues and eigenvectors, which we'll be trying to eigenvalues. We'll be working on that. So, and it comes to back to this dynamic analysis, right? We work on this dynamic analysis, as I was trying to refer here. And non-linear analysis. When I say non-linear, it has so much, guys. So now everything works on non-linear material non-linearities, because it is working on elastic limits, geometric non-linearities, sudden large deformations. We'll be working on something else, hyperelastic materials. Mr. Krishnakant, once again, I come back to Krishnakant, since Krishnakant wants to work on plastic parts, where exactly the material behavior is non-linear. So we'll work with non-linear analysis, which we'll be working on that. Okay. Once we are done with this, right, composite materials. So we try to understand the composite materials, but this is not at this point of time. I prefer not to work on this analysis of composites, because my entire research is onto composites. At this point of by during these 5 days, we'll not be touching this composite materials. Okay, at this point of time. So make a note of it. This is also one of the area which will be working, which answers or analysis FEM can work. Thermal analysis, yes, we work on the thermal analysis. We'll try to give few examples, try to understand how the thermal analysis works here. So transient thermal analysis, thermomechanical analysis, each and every analysis we'll try to go with this. Next, you have something called as fatigue. One of the area where it is predominant nowadays, high cycle fatigue. Fatigue is mainly responsible for sudden failure case. If you can recall your concepts from your basics of engineering, fatigue is very dangerous, because by the time you see the crack, it would have been failed. It never gives you a chance. There is no chance of deformation in case of fatigue, because always it is always good that most of the components gives a prediction, obviously gives a visible indication that it is going to break. But if it is going to fail by fatigue, there is no chance that visible indication cannot be happening at all. There is no chance of visible indication. So here you were someone is asking the life cycle of the product. Okay, this life cycle of a product, what is the life cycle in this case? If you want to know, this is what exactly need to work. Okay, fatigue analysis is what exactly need to understand. I think Pradeep has mentioned about this, right? Pradeep?
Yes, yes.
Right, great. So this is life cycle of the components. If you want to understand this, it is fatigue which you need to work. We'll try to touch upon this basics of fatigue, what exactly happens. And CFD guys, CFD is one of the predominant area nowadays. Fluid flow, all things. So we'll try to work on that. Okay. Now, and finally, yes, optimization. Optimization is a basic study. I feel that every area we cover, optimization is by default, it is there. Optimization is either you, within the available resources, try to give the best kind of structure, the shape. This is what optimization. So we can work on this optimization every stage. So optimization works on this. So parameters can be optimized, different parameters. So each and everything we can work on this optimization stress. These are the various capabilities where FEM can do slowly. What exactly is finite element analysis? We have already seen. The other perspective which I'll be trying to talk about is a computerized method for predicting how a real world object will react to the various forces, external situations. it can be a force, it can be a vibration, anything. So how the system is going to react, we try to solve with real world situations. Okay, so real world situations are many ways when we try to talk about. So here the interaction between the product and the real world, which we'll be trying to work out. So let us differentiate what exactly is a conversion process and what exactly this process of simulation works. If you see on the screen now, I'll have got two different processes. One is the conversion process involves creating of physical prototypes, guys. Okay, now what we do is we create a model, CAD model, then create a physical prototype, test the prototype. If test fails, what we do, we redesign it. Okay, we redesign it. Then this once again redesign this, and once again go for a physical prototype. Once again test it, and if testing is successful, then we go for build. If testing is not successful, we once again redesign and do it. This is the iterative process. This is a conventional system which worked, but this conventional system, two disadvantages is your cost and time. These are the two major issues which happens. But in case of this simulation kind of thing, finite element model, what happens is we create a CAD model, simulate it. Okay, we simulate, try to understand and redesign. This is also a pretty, but obviously what happens is simulation will happen on the computer. Small parameters we are trying to change it. So redesign it and create everything. And lastly, but what happens is a prototype, sometimes in some areas prototype is always necessary, but only one prototype we create here, not many as in case of conventional process. So only one prototype, so time, it saves time for us. It is easy, fast and cost efficient design cycles will be developed using FE. So benefits, we know it, obviously. Yes, I don't want to waste our time, your time especially on this. There's lower development cost, shortened design cycle, number of prototypes can be reduced. A more robust and reliable finished product is done. This of why adoption of FES software is most important, guys. So one is increasing computing capabilities is coming to picture. Cloud-based systems. It is now the cloud. I'll try to introduce the software today as if maybe in this course. What happens is the software which works on cloud-based. This is one of the beautiful things which can be done nowadays. Computing capabilities increased. Okay, cloud-based software came to picture. Easier to use, low cost. Okay, for the software, and yes, this comes with additional package. It is not only analysis, as I was trying to do, it is design and modeling is also coming into the picture. Design and modeling can be done using analysis packages also. That is what exactly happens. Now let us straight away jump into the steps in FEA, how the steps FEA is working. Now when I talk about steps, so what I'll be trying to teach you is, for a front-end user, how FEA looks. I also explain. For a backend, how the FEA, because one of the important requirement from you guys is you should be, see, from my side, my intention is you should be able to work independently, guys. That is what exactly one of your participants said. You should have a knowledge to work independently, guys. Okay. So if you want to work independently, what happens is you cannot depend on the software which your industry is supplying, or let me say on particular software. You need to cater your knowledge to the softwares which is available to us. That is what exactly important thing. Because if you go to a industry, since you are working in here in this particular industry, you cannot expect them to purchase a software which you know. We should have a knowledge of working on any software. This can be happening only if you are strong at the backend. Okay, the concept should be, fundamental should be very strong. Then only I can be able to work in every software. So I'll be trying to talk about the steps in the front end as well as at the backend. At the front end, what exactly? Now here, let me talk about this for a front end user. Is how exactly problem scenario, how he sees problem scenario. The general scenario I talk about, then I will talk about front end user, how he sees the scenario. The scenario is something like a physical problem has to be converted into a mathematical model. This mathematical model, okay, is solved by using a numerical method. This is the scenario. Okay, the scenario is very simple. If we on one of the numerical methods is FEM, the general scenario which I have explained. So a physical problem is there, which we try to convert this physical problem mathematical model, and mathematical model will be converted into numerical model. Now, how the front end user looks into this? He sees in this status. He sees into three stages called as preprocessor, solver, and post-processor. Yes. This is a scenario where the front-end users always looks. He sees that there is something called as preprocessor, means before processing. Preprocessor is something like a physical model is converted into FE model. He don't see back end of this. Okay, no mathematics, nothing here. So the results, how the results are interpolated, all the things he don't see into this. So here the physical model clearly he says the preprocessor, so many works of preprocessor. I'll try to talk about more about preprocessor now. Okay, then there is something called a solver. Solver, very complicated issue which a front-end user always believes, because till now I have gone through industry. I have given this workshops for I have recently trained for test also. Okay, recently even some of the experts from GE I have interacted with them. The people are less worried about solver guys. What happened is they failed to address many error issues. That is a major problem when you don't understand what exactly solver backend works. That is a kind of something black box which happens inside, which we need to understand. And something called as post processing. Okay, this is how a front end user always looks. So let me give you a small idea about these three areas. Preprocessor guys, which you see, this is a something converting your geometric model into FE model is called as a preprocessor. So I repeat, preprocessor is a technique of converting your geometric model into FE model. Okay, what exactly this means to us? So how do we convert? First question is how do we convert? The geometric model is one which is developed in CAD software. This never will be having same quality of physical model. Keep that in mind. This geometric model virtually it will exist. It will never behave in real time sense. Let me say, for example, I want to model a pen, or I want to model a table. Modeling a table in the CATIA software or SolidWorks is very simple. We can create it. But when I ask a question, do this model exactly behaves as a physical system? Is 100% no. The reason is so many parameters are missing there in physical model. In SolidWorks, you do not have so many parameters which you need to give. What are those parameters which are missing? Okay, these are the parameters which you see on the screen now. These are the parameters which are missing in a geometric model. Loads and boundary conditions I have not given. You have not given any supports to the model which I have done in SolidWorks or some modeling software. What kind of material properties? Some softwares are now we are trying to take the material properties. But what happened is material properties they are trying to take only in terms of density. But behavior like Young's modulus, Poisson's ratio, no such properties we have given for models. So, and what kind of whether it is continuous, decrease of freedom, meshing, decrease of freedom, all things are not available. So what happens is geometric model was virtual. It never works. It is not of no use. So, but our work is not like this. Exactly representing a physical entity into a real-time scenario is what FEA. So, in such cases, what we try to do is apply all such things. So many parameters, still more parameters are there. So type of element, what kind of element is this? I'll be trying to talk more about this element now. Meshing, what kind of meshing we need to do, what kind of analysis we are trying to solve on this model. Okay, what kind of material properties and loads, boundary conditions, is it hyperelastic material or what kind of material we are working on that? And how do we convert this geometric model into finite element model? Now our concept is to work take the outcome of preprocessor is finite element model based. So here what happens this the physical model something looks like this. So finite element model is looking like this. So the first model doesn't work. That makes no sense for us. In real-time user, it may not make much sense. But as finite element model can be analyzed, can be done. I can apply all the things because it has got all these capabilities. So once it is done, this is what we call as preprocessor. So here preprocessor, this is what exactly happens in preprocessor. We create a geometric model. The geometric model which can be created, which looks something like this. So this all the softwares, the many softwares are available to create such geometric models. So you do Boolean operations, create geometric models. Once you have done, define. This is what exactly we need to do now. Define the finite element model. So by applying all these conditions, whichever I explained here, like loads, boundary conditions, elements, what kind of elements, how many elements we decide. Okay, a geometric model will be converted into finite element model. This is what the preprocessor will do. Okay, and define operating environment here. Most important, guys. The finite element model will have also a operating environment like materials, contacts, forces, constraints, boundary conditions. All this operating environment we need to create it. Then only this will exactly represent a actual physical model. Else there is no point in working representation. So we fail in pre-processing, guys. Here, most of the times I'll be concentrating on pre-processing also now. Okay, most of the times pre-processing where exactly we fail here, because if I think Anand, you are asking about pre-processing, right? Is it pre-processing or post-processing, Anand?
Yes, pre-processing actually.
Yeah, good. Pre-processing, right? So yeah, so here you fail, guys, right? I'm telling you, we fail in pre-processing. Everything is gone. As Anand has rightly pointed, he identified the area where he need to work, because it is the pre-processing, guys. Pre-processing you have failed. Now your pre-processing is representation of physical model into finite element model. Means representing this physical model which you are looking right now. I'm holding a pen in my hand. So this is a physical model. Now I want this pen exactly behave like a pen only on the computers. So see the difference. The virtual model should also behave, the virtual pen which I have created should also exactly behave the same way which I have created here. So that is what your pre-processing. So your pre-processing completely works on converting your physical model into a computerized working model, which is called as finite element model, which exactly can recreate the capabilities of. So I can say that in better way, in physical societal terms, I can say cloning, guys. You have cloned it. So exactly, if your cloning went wrong, you are gone. Means a cloning exactly with the properties, with the way, behavior, everything. You are going to clone your physical structure into the system. The process of cloning, first create a geometric model, then take it to give all this boundary conditions, operating environments, create it, and make a clone. Okay, yeah. Do you have a, operating parameters means environmental conditions as well? Yes, true. Swandesh, yes, environmental conditions also. Boundary conditions, temperature conditions, environmental conditions which we are going to work. All these things works on this operating conditions. Not only this. Okay, depending on the situation. Let me say, for example, wear studies. If we are trying to do wear studies, okay, operating conditions talks about this also. Okay, because where is this one of every parameter. So yes, all the things comes. Sometimes moisture also plays a more important role. Okay, and especially in case of thermal analysis, the environmental conditions prevail, right? So this is what exactly happens in this case. So once you are done with this, uh, the materials, which is most important, guys, material properties which we give. Now different examples of materials you have. The softwares can work with ABS, plastic materials which I have shown here, and all other materials in MATLAB also you can work. Okay, you can get the description of this materials there also.